So, let's review the last session. Do you have any questions? What is the cloud, by the way? What is the cloud?
It's
What is cloud computing? Come on.
it's a bunch of data resources or processing and storage resources that can be allocated dynamically as the user needs it.
Great. And why it allocated dynamically?
Processing power and space.
And the reason of that is because we want to use the resources as much as possible. So, how many students? 30 students around. So, we want to access about 10 servers. So, we allocate the resources as a virtual machine for each of you guys. You get the benefit of that. And what's the advantage of it? You do get access to the really, really powerful and strong resource. And it's not necessary to care about what's going on inside of that. That's interesting, yes. You don't worry about is the RAM is corrupted or not, is the hard disk is not working properly or not, because all the things are managed by the admin. And this is your personal computer, but somebody else is the charge of that. Okay? So, what kind of cloud computing topologies do we have? Nick?
Infrastructure as a service,
Topologies, not the services.
hybrid cloud, private and public.
Great. And what's the advantage of the hybrid cloud?
You can have parts of it that are closed off to everyone else. Like,
So it's more secure for the tasks that are not necessary to take care of them. You can push it in the public cloud for your own tasks, such as your own project. You can have it in your private cloud. How about the federated cloud? What is the federated cloud? So today we are going to discuss about some kind of application of data analytics in the cloud. The federated cloud in this term is very important. The reason of that is, as you remember from the last session, we do have a bunch of cloud providers such as Amazon, such as Google, such as other private companies, Rackspace in San Antonio. So all of them are necessary to have. Why? Because each of them has its own capability. When you want to run a huge data with a complex algorithm, okay, some of the data is allocated in one cloud, such as Amazon S3 or other services by Amazon, but you get the advantage of the Google to play with your data. So actually, you do have two kind of clouds simultaneously, and they makes the federated cloud. But this is the just the application. Okay, as a real federated cloud mentioned as something as much powerful as possible. Suppose that you do want to access to how much RAM. By the way, what's your experience about RAM so far? 16 gig? More than 16? Have you played with 100 gig of accessibility to the RAM? You know what does that mean? It's so much. Oh, you can play a lot of things with that. So, and suppose that you have an account in a cloud provider. This account is corrupted. If it is the federated cloud, the other cloud provider is responsible to provide you that resources that you pay for them. Is that clear? In a simple word, you access to a lot of cloud simultaneously, and always it is guaranteed to have your resources. Okay. Let's move on. What's the function of hypervisor in the cloud? Please. What's the function of hypervisor? It's a manager, yes? It's a manager of your cloud. It decides the virtual machine is allocated to you or not. And it's managed all the resources, actually. Okay? If you don't use your virtual machine, it is not necessary to allocate that resources to you. Okay? So stop it, allocate that resources to somebody else. And how it can be happen? You remember? Layer by layer is controlled. Yes. The hardware is same. Virtual machine monitoring hypervisor is the layer on top of that. VMs, each VM has its own OS, and each OS has its own applications. Okay? So we see the cloud for these two sessions as the user, as a tenant, actually. Now, we're not going to deep to the what's going actually inside of the cloud. But this is that is very necessary to remember. You have access to the same hardware, which is allocated to each user, but with the own request about the OS, okay, and other things. So, what are the services in the cloud? As Nick mentioned, infrastructure, platform, and okay, so which one you prefer to pay for that? Based on your job, yes? It is not necessary to pay 100 for the resources that you don't want to use it for all the time. Yes. And somehow you just need 2 instances. By the way, what is instances? What is instances?
Your specific set of hardware that you're using.
That allocated by the VM. Yes. Just try to make the distinguish between the instances and your computer. Instances is a portion of the resources that you request and it is provided to you, and you do have access to that based on your usage, okay? But your computer is the actual hard drive that you are playing with that. Okay, so let's move on. Okay, let's reach the point of the application. Cloud and robotics. Actually, robotics, one of the hottest topics nowadays, since there's a lot of resources provided for the robots. And, you know, it has a benefit for the robots. What do you think? What is the primary benefit of using the outer resources for control the robots and for getting access to the robots? What's the primary advantage of it?
Let's say you get a distributed set of information. Every robot can access all the same information.
Yes, actually yes, but I was thinking about saving the resources of the robot. What are the resources of the robot? Onboard computer. Battery. Yes. And everything that can be handled in the cloud. Yes. You can get the advantage of them. Why battery life is important here? Computer board consume a lot of energy. Yes. If you offload some of the tasks of the robot in the cloud, computer board doesn't use as much as before. Yes. As much power as before. So in that way, you can save the energy and your robot can run more. Yes. So, the other advantage of the robots, as Nick mentioned here, distributed system. Previously, we do have the network of robots that was working together. Okay? But there is a downside of these topologies. In that term, each robot in the network should work face to face. Yes. That face to face is going to be complicated. Yes. If we do have a center that controls all the jobs, all the tasks, and all the missions by the robots, it's going to be perfect. Yes. There are three topology of the cloud robotics so far. Peer-based model, proxy-based model, and cloud-based model. Cloud-based model is what is so advanced. Because you can get the advantage not only by the robot by itself, but also by the cloud. And this cloud should have an advanced architecture to control things. Okay? Just trying to mention what are the tasks of the robot. If you want to design a robot, for example, for catching something, the robot should be capable of movement, yes, track, and what else you think? Please? Vision. Vision. So, what is vision? What is vision?
Video to a camera?
So, what's the function of that? As same as our eyes, yes? We see, we understand, we distinguish, and we learn through our arms, yes, when we are doing something. So, this is very important. And our brain controls all the information that comes through our eyes, yes? This brain is going to be in the cloud when we want to implement the cloud-based provider. So, let's move on. Big data. You're working in your project of data analytics, yes. So, suppose that you will want to handle about, not so much, just 2 terabytes of information. Can you do it in a laptop? Why? Because even if your hard disk can support that, your RAM couldn't, yes. And the other things, if you treat your RAM to handle that kind of data, your cache should support it as well. What's the difference between the cache and the RAM? Which one is faster? Cache or RAM? And what's the difference?
Cache smaller, easier to like access.
Cache is smaller, yes, but easier to access by who?
By
the CPU. Cache is available directly to the CPU, so some of the information is handled in the cache, which is the layer 1, and then the RAM is layer 2, and your hard disk is layer 3. And the speed is improved in layer 1. Okay? So, let's move on. Data analytics and machine learning. Machine learning is the things that we're going to focus today on that, in parallel with other topics. So, actually, what is machine learning?
Machine learning, using a data set to train, essentially train whatever machine you're using, and then from that it can determine, given another set of data, what you're using.
Yeah, all right. Machine learning is training the machine to do artificial intelligence tasks. Yes, such as Google Drive. Yes, Google Drive is the card that can handle all the server functions, and it can move and handle all the things. Okay, so can you provide me with other example of machine learning applications?
Like facial recognition.
What is that?
Facial recognition.
As an example, can you explain more?
So like there'd be a huge set of data, and then that would be trained on. So then later on, for like a random, any given image of a face, or like a room with one person in it, it could recognize the face in the image.
Yeah, we do have it in Facebook, yes. Machine learning is a huge project in Facebook, IBM, Google, every telecommunication nowadays. So, in STM. So, it's a really futuristic world if you have a production in that area. Okay? So, all of us are dealing with our bank account or credit card or something just like that. Fraud detection. You know, if somebody fraud your card, you can understand it less than an hour, yes? The company just emailed you a call, okay, your credit card is active and we're gonna stop it and then, yes? All these tasks are done by machine learning. Do you have any view of how it can be handled fraud detection? How human understand what is the fraud detection? What is the fraud? Yes. We try to teach the machine to detect the fraud. And what is the machine here? The machine can be hosted in the cloud. Yes. Many people, many information. What is that? Big data. It's going to be the main process of that big data. So it is needed to have a huge machine, powerful machine to handle that kind of jobs. Yes? Okay, so other examples. Other examples. Daily life. Daily life. Anything that human is doing can be implemented to done by the machine, yes. Am I right or not? Actually, I don't do anything. But most of the tasks, most of the daily tasks. Okay? And it means that it should be a complex algorithm behind of a lot of information that should be handled by that algorithm. Okay? And it should be implemented and it should be provided output. And in some cases, it should be synchronized with the robots to handle some kind of task. You can imagine a system that includes many parts, and these parts is needed a powerful machine. So this is the reason that I mentioned all these examples for the cloud. Okay. Programming. Are you familiar with Python? Yes. How about R? No experience with R? Okay. C++. You know, most of us did pass the C++ course in undergrad school. And what else? Java. All of them can be useful in this area. But I mentioned Python and R programming for two reasons. There are a bunch of libraries, real libraries, that provided and you can access them free of charge and play with them and produce a really state-of-the-art product. Many startups are handled by these, actually are started with Python and R programming. So to some extent, we can talk about Python and R today, but continuing them is going to be it's required more efficient, and maybe in the future in other classes you can get advantage of these two. Okay, some machine learning algorithm is listed here. Linear efficient logistic regression, decision tree, SPM, net-based, k-nearest neighbor, k-means, random forest, and so on. Most of the most famous algorithm nowadays, it is not mentioned here. What is that? Neural network. Neural network. Neural network is the connection between nodes, layer by layer, and producing a complex, huge amount of node that can be handled not the easy tasks, such as driving. Okay? If you just search Google Drive, provide you, okay, we're going to implement deep learning by the use of neural network or some other advanced algorithms. So we're going to talk a little bit about this subject today as well. There are some sources that can be helpful for you guys to take a look at them. Just take a look and get the overall idea of what's going on inside. It isn't necessary to dive. Okay. For your project, you're going to have the access to the ASAP cloud. Actually, it is a fog. What is the fog? Fog is a smaller cloud that in industry, actually, it is used as the first interface of handling the information. Okay? And this cloud is provided in the ACE lab and AFL lab, Dr. Jamshid's lab. So, and OpenStack as a cloud manager is the hypervisor for these to the cloud. So let's go and review how we can get benefit from OpenStack. So, what is OpenStack? Do you remember from the last week? What is that? Free software for cloud manager. Agree? Is there an easy way to do that? actually no, it is not easy. OpenStack has many parts, such as, do you remember? Suite, Nova, and so on. But we don't want to talk about that complexity. We just at first want to get in touch with the dashboard that is provided by OpenStack, and the source of OpenStack is from Rackspace, yes. And we just play with the dashboard of that, how we can make the instance. The instance is what? The instance is the virtual machine that provided for you. And then we just implement some algorithm of machine learning on top of that. Okay? That's it for this session. Thank you.